Hi, everyone. Thanks for joining today. It's a very full house. We're going to get started on time because we have hopefully a fairly full schedule. My name is Alicia Witt-Charlson. I'm here from Lawrence Berkeley National Lab, and today we're hosting a workshop on exploring patterns and transforming complex data to answer complex questions. I am joined here by several other people. So Steve Diggs is over there. He will be presenting. So is Daniel in the front, Rachel, and Natalie. And we're all here representing the ESIP Data Stewardship Committee. Okay, so today we're going to talk about data integration. And I want to give you a little bit of context about what it is and why the Data Stewardship Committee wants to talk about it. Then we're going to hand it over to our in-house speakers. They have a couple of slide decks they're going to go through to talk about their own data integration experiences. And then we're going to do a breakout session where we want to hear about your integration stories. So I'm sure a lot of people in the room have a variety of integration experiences, and I'd like to capture those as best as possible. And the goal for the workshop for today and for this meeting is for us to start to understand some of the data integration questions and the data integration challenges by the ESIP community. And of course, to celebrate any successes that you've had. Okay, we do have a Slido session throughout this talk. So please get your computer or your phone up and ready and share on what made you interested in coming to this session. And I think there's still one open chair up here in the front table. Thank you. If anyone wants to sit. While you're doing this, I do also encourage you to open the shared notes document as well. The online people have access to it. I just put the link in there, but there is going to be a component of the breakout where you might want to access the shared notes doc there as well. So there's a lot of complexity that comes around this. Yep, that was in the title a few times, so that makes sense. Talks about ocean data, complex questions, integration, heterogeneous data harmonization. Great title, thanks. We kind of made it up, so appreciate it. And somebody's here for Natalie's talk. Yay! Okay, I'll go ahead and move on to the next question when this last, oh, you pushed the type. Okay. Steve told me to come. That somebody says, Steve told you them to come. That's why they're here. I missed that earlier. Is that why everybody was laughing? Awesome. All right, so I'll go ahead and move on. How often do you quote unquote integrate data? It's very loosely defined at this point, so that's okay. What is your feels about how often you integrate data? Finding this workshop at a ESIP meeting, I sort of figured there was going to be probably quite a few people that would identify with this question. Oh, sometimes just tied with regularly. Anybody watch? Is everybody ready for the Olympics? I think that starts on Friday, right? Sometimes just overtook regularly. Excellent. Oh, tied again. It's close race. So we do Slido polls with my team, and sometimes I think they just respond because they like to see certain patterns in the result. So it becomes a very non-accurate poll pretty quickly. Okay. And then please share your role in your organization. How do you define your job? I don't know counts. That's fine. I define mine as a cat herder, so take that however you like. If that makes it through how I describe my role. Scientist and data manager are coming up a lot. Scientist and data scientist. Data manager. Excellent. Scientist and data manager seem to be ooh, retired. Hooray. Therapist. Awesome. Thank you for that. Instigator. I have guesses on who that might be. Okay. So we're going to talk a little bit about what exactly is data integration and to whom that term means different things. So I'm not really here to define what data integration for you are, because I believe everyone has their own perspective on it, right? We saw scientists on there. They might have a different perspective on data integration than a data manager might, who would have a different perspective than a software engineer. And so I think there's a variety of different perspectives on what data integration is. And that's great. I mean, I think all of those are correct because we're all dealing with data every day. And so I think there isn't a right answer to any of the stuff that we're going to talk about today. It is just your experience, and that is the right answer. There are challenges that you've faced. Those are true challenges. There are successes that you've had that you like to celebrate. Part of what we're going to try to do today is take a slightly elevated perspective on data integration challenges. We can quite easily get into very domain-specific data integration challenges. The goal for today is to talk about those domain-specific data integration challenges, but then elevate it to figure out, are there commonalities in what you're struggling with to what someone else is struggling with? So think about that a little bit today. I'll remind you as kind of we go through the session, but that's sort of the goal for today, is try to figure out what the generalities are, what the commonalities are between your domain-specific data integration struggles and what others might be doing on as you're talking about your shared experience. Okay, so I'm going to propose data integration as a spectrum. I completely made this diagram up. It is not meant to be a fancy infographic that Creative Services did anything with. But I'm going to talk through it a little bit, and then I want your thoughts and opinions on it. So if we were to take data integration as a spectrum, you could be integrating a single data type from multiple different streams, completely legit, or you could be integrating many data types, potentially from a field expedition. So there's a variety of different data types and structures that go into just that spectrum component. It could be data frequency. How do you integrate discrete sampling, time series, where you don't necessarily have information between those? Or how do you integrate multiple continuous data streams? Even more fun, how do you integrate discrete and continuous data streams, right? So there's a whole layer on that as well. Maybe your work is focused on a very targeted integration. Maybe you already have known entities that come in and you have a specific question, you process the data, you have a workflow, and then you deliver it out. That's awesome. People are stoked because they don't have to do it. Maybe you're still in exploratory mode. Maybe you're trying to figure out what the best frequency of sampling is, or the best metadata to kind of capture the context for it. So there's a lot of exploratory analyses that go into understanding what the right approach might be. And then there's the FAIR data principles, right? So findable, accessible, interoperable, and usable. So data integration requires there to be metadata. It requires there to be persistent identifiers for anybody that went to that session yesterday. Formatting, understandable formatting, interoperable formatting, and then of course enough provenance so you can actually do something on a reuse perspective. So I'm going to put that out there as just a way to frame different perspectives on what data integration might look like to you. It might not capture your perspective. And so I would love, what do you like or dislike about this? How does this land with you? And I think I need to go to, okay, here we go. And I'm not posing this as any sort of like ESIP structure. This is just to kind of get you thinking creatively for when we do the breakouts and when we start to talk about challenges. And I won't take anything personal if you hate it. It's totally fine. Not sure I understand it yet. Fair enough. Absolutely. Okay, like the data integration was there. It's been identified with targeted and fair. Machine dimension resolution and uncertainty. Excellent. Data QA/QC. That's a good one. Qualitative and quantitative. So good. Yeah, I like that. Scale and then is this a one-off integration or regular production workflow? It's describing an elephant. I have legs. What do you have? Structured and unstructured data. That's good. Yeah, these are great ideas. Excellent. Okay, and then where does your experience fall on the spectrum? So someone mentioned targeted and fair. Just to kind of get a shape in the room. I'm all over the place. Oh. Continuous, fair, heterogeneous data. Targeted. Wow, a lot of people call that all of it. Oh. Yay, and I'm sorry, I don't know. It's a lot to try to integrate. Random discrete data. Okay. Yeah, I like something to figure out how to capture that heterogeneous. Okay, I'm gonna go ahead and move on. So I want to change it a little bit to kind of capture, there are components around a lot of data integration that happens across different disciplines. So everyone's fairly comfortable with the FAIR principles, findable, accessible, interoperable, reusable. From my perspective, so I come from my biological sciences perspective. So my understanding, and whether this is true in the room or not, I think this covers a lot of what people need in order to find data, access data, understand file types of the data, and have enough information about where that file came from to reuse it. Is that fairly decent consensus? I would argue, however, though, when you open the file, and this came up in the identifiers conversation yesterday too, once you open the file, like all game is off, right? Like you might have an Excel spreadsheet, you know exactly what kind of Excel spreadsheet it is, right? Because of the extension, but when you open it, there may or may not be any labels on any of the data. It might be color coded, that means something to the grad student who made it, but not to you. So we're pitching this idea called, okay, find the data, but then you have to cope with it. Um, and so I'm just putting this out here. It's not when I put this slide deck together, she was like, I've never heard of COPE. And I'm like, we haven't published it yet, but we're working across, I actually do have NASA representatives and some NIH representatives. We're kind of trying to put together this idea of like, what does it look like to cope with complex data? And so we're prepping this for publication in Nature Microbiology as a perspective article. So I'll let everyone know when that goes out. I ended up with like 26 co-authors, so it's gonna take me a little while. But the idea is that once you actually get those files and you're able to open them and you have enough provenance to you can actually figure out where they came from, you still have to make them comparable. So there has to be some idea about what units the measurements were done in, if they applied ontologies, were the measurements actually comparable in time and space. And then you need to organize it all, right? You can't just throw it into a notebook and expect that notebook to know what to do. Even in the AI section yesterday, there's a ton of cleanup that has to happen, an organization that has to happen before you or machines can make any sense of it. And then that's what enables us to do predictions on it, right? So from a biological perspective, I can sequence a genome and it is just the observations of nucleic acids, so ATCG over and over and over again. I can tell you what that organism is taxonomically, but that requires a database and an algorithm and assertions that I've made on that observation data. So now I'm making a prediction that this microbe is a bacillus, but that's just a prediction based on a priori knowledge. So even that level is no longer just data, it's now an assertion that I've made about that data. And so what we're going to argue in this paper is that this is an engaged effort. It takes a lot of people to be able to build these databases, test them, validate them, go back to them with experimental protocols to say your prediction is accurate or not. And so there's a whole, I think, community effort that needs to happen in order to cope with complex discipline-specific data. Okay, so what the goal is for today is to think through what are some of these shared challenges when you start to move into different areas in that data integration perspective, right? From that whole spectrum of continuous to discrete or targeted to exploratory. What are some of the challenges that you discover? Okay, I've got this pipeline and I want to integrate a new data stream. What are usually the main things that come up? And so myself and my co-presenters came up with a couple of different potential challenges that we felt identify basically some of the talks that they're going to give. So silos of excellence. We all live in our own disciplinary silo and we're all excellent. When can you start to get across some of those silos of excellence and start working more interdisciplinary or transdisciplinary? Scoping. We all have really good ideas that are really big. And then you realize that you're still human and you can only collect so many samples on a time series without needing to sleep. So there's asking too much of what you're trying to be able to accomplish. And then there's also maybe not enough data to answer your question. So maybe your question is too big and the data just doesn't exist yet. Data bias. Are you making sure you're asking the right question with the data that you have? And there's many layers of biases that we can get into. And I think we're going to try to capture some of that in this publication, but just making sure you're asking the right question based on the data that you have. And then space and time, both in data, right? It's hard to cover all of the space and time, but then also reality, your time, the space on your servers, the space in the compute cluster. And so space and time, I think, is another common challenge that people have. Okay. So with that, I'm going to hand it off to Rachel, and she's going to introduce the speakers.
So I'm going to introduce all of our speakers at once, and then we'll walk through their talks and then have a question and answer session based on the thoughts and questions that come out of our presentations this morning. Our first speaker is Daniel Segesman. Daniel's work spans geology and paleontology, as well as geospatial and data sciences. And today, Daniel will be sharing about a data integration story about working with fossils. Our second speaker will be Steve Diggs. Steve's work spans many aspects of technical data collection, data management, data policy. He will be sharing a story about data integration in ocean sciences. And our third speaker is Natalie Raya. She will be speaking about an interdisciplinary data interoperability study And she has a background in geology and data use interoperability in publishing and earth sciences. So without further ado, Daniel.
Are we good on Zoom? Okay, so it's sharing a specific window. Okay. So All right, cool. All right, so thank you for that introduction. Like Richard said, we're gonna be talking about fossils and rocks, and it's kind of weird because fossils, 99% of the time, come from rocks. But then we extract the fossils, they're in a separate database, and we have a separate database on rocks, and then we have to go and put the fossils back in the rocks in order to do large scale data science with them. Right, so it's a little bit ironic in that way. But that is what I'm going to talk to you today. And the name of the game for me is to stay on topic because I get really excited about the process. That's not what we're going to hear about. But I am going to describe to you this data integration case study as I'm really interested in the origins of animals. The fossils you're looking at on the screen are some of the oldest known animal fossils in the world, right? So some 575 million years old. And we don't know why they show up then. The Earth is supposed to be 4.54 billion years old. And it's only 570 million years ago we get these guys. But following this period of the Ediacaran, where we have these oldest animal fossils, that's the geologic period that rocks at that age, where we get these fossils, we then follow with the Cambrian explosion of life, which you may have heard of, but if not, right, it's where all modern phyla show up in the rock record. And even some phyla that still do not exist today. But they have all these characteristics where they get spines, they start preying on each other, they start doing all of these mobile things, higher energy. And so this transition from the Ediacaran into the Cambrian and the types of fossils. And so I'm really interested in Earth systems as they are around the origin of animals. And then this transition from the earliest animals, which are strange, weird, makes them all sorts of fun, into these also strange and weird creatures, but different or strange in a different way, we'll say in the Cambrian. But the data platforms that I use to approach these analyses is the first one I'm going to walk you through is MacroStrat, which is a database of rocks. That's a database. What you're looking at is a map of the world, and there's all these colors, and that corresponds, if you're familiar with the geologic time scale, it corresponds to those colors that are on the geologic time scale. So you're looking at both space and time represented on the map and the rock layers that are there. And if you're interested, you can follow along on macrostrat.org and go check out the map. And there's an app for that. You can check out Rock. It'll tell you, you can take that with you on your phone. It's powered by MacroStrat, and you can see where you are in geology, But as for my party trick, I've selected Asheville, and we can actually look at the rocks underneath our feet here. And they're pretty interesting, at least I'm biased, so I think so. But they're from Snowball Earth, if you've heard that term before. Right before those oldest animals appear, there's a period where there was 50 million years of continental glaciation where we think glaciers covered all of the continents. Some of you may be used to thinking about the last glacial maximum where there were pretty large continental ice sheets, but this is that, on a couple order of magnitudes greater, right? And so those rocks are underneath our feet here. And so we can see here that this is a MacroStrat. We have geologic maps, right? We have, not only do we have a specific point you can select and see geographically where you are, but you can also look where you are in time. So in the stack of rocks, right, that is there as well. All right, so again, MacroStrat is a data platform containing rock units and their characteristics. So it describes what the rocks are made of, right? So just saying there's a rock here isn't descriptive enough to be useful. We want to say, what type of rock is it? Is it sedimentary, igneous, or metamorphic? If it's sedimentary, is it carbonate, sandstone? Is it siltstone, mud, etc. Right? And so not only do we have a geologic map that shows you what the surface rock is in an area, but we also show you the entire stack of rocks so that we can actually see, if you take if you were to lift up North America and look at it from the side, you could see the stack of rocks from the youngest rocks on top to the oldest rocks that make up the basement or the core of the continent. All right, so that is kind of the idea of how MacroStrat works as a data platform. And so there's a lot of power in that we have our individual observations that geologists have been collecting for over 300 years, right? And we cite papers from 1800s, 1700s that have the original rock descriptions from areas in some cases. And then we put them into these columns that are represented by these interpolated polygons. And then we have all of these together and we can do things like make quantitative time series of the amount of rock through geologic time. And there's a lot of interpretive power with that ability. So the other data platform that I used is called the Paleobiology Database, which some of you may be familiar with. But again, if you're not, it's a fossil database. So it's a database of fossils. And in this case, again, we have our party trick here again, where we have Asheville, right here. And then some of the closest fossils are actually Ordovician age. So some of the closest fossils reported in the database, 400 some million years old, when there were reefs and shallow marine settings in the area around us, or where this would be now. And so the paleobiology database, it has a fossil collection. So you have a collection and then you have a list of fossil names that are associated with that collection. That's a specific point in both, geographically, so where you are on the map, but then also it associates it with a specific rock unit name, right? So again, it's putting you somewhere in that stack of rocks, right? In this case, it'd be pretty far down since we're 450 million years ago. All right, so that's these two data sets, and a lot of the work that I do is to mesh these two together, right? So MacroStrat is built for rocks, paleobiology database is built for fossils, and they're linkable by that rock unit name, right? So those fossils are associated with a rock unit that they come from, and then MacroStrat is, of course, the stack of rocks, and each of those rock layers that are considered unique have a name associated with it. And so we can link those data sets through that. And so there's some almost 15,000 Cambrian age fossil occurrences for just North America in the paleobiology database, and only about 320 for that period with the origin of animals, right? And then that's linked to, a bunch of different rock units, which is somewhere on the order of 500 or 600 altogether. All right, and now this is a graph that we can take from the paleobiology database. And again, some of the interpretive power of it is we can take the number of fossil occurrences, the number of those names at the generic level. So if you're familiar with taxonomy, we're looking at genera in this case, and we can look at just counts of how many genera there are through geologic time. However, the question I have for you, should this biodiversity curve be taken at face value for this data set, right? So the paleobiology database is volunteer entry, right? So people enter data that they're working on. It is not a comprehensive database of all fossils that exist that we know of, but it's rather things that are entered by people who are in different research groups and working for you. All right, so this is a good time to switch to slide. So what challenges do you think that this system faced based off of the limited information I've been able to tell you about MacroStrat and the paleobiology database? What sort of challenges do you think may have come up in the process of joining these two data sets? Oh yeah, mismatched taxonomies. Yeah, the paleobiology database was built by paleobiologists who are very interested in taxonomy. So it is an extremely strict, rigid, structured, and standardized system within the paleobiology database. Organ bias, time bias, lack of persistent identifiers, absolutely the case to pretty much all of that. There are no persistent identifiers used explicitly in MacroStrat. Okay. All right, so we'll go ahead and move on.
Just go back to your.
Yeah. All right, so some of the challenges, I'm gonna run through these pretty quick, that did come up is that MacroStrat and the PBDB, shortened to paleobiology here, have minimum data requirements for entries, but allow for greater detail to be entered included. So the forms have some required fields, but there's a lot of optional data you can add in terms of metadata or collection data. Instead of persistent identifiers, a lot of these samples come from museum collections, for instance. It's been entered by many users for different purposes, right? There's a lot of people who have different research goals when they enter, especially the fossil data, right? Maybe they add, with the fossil data, there's ability to add a bunch of measurements, like how wide is the shell? How deep is the shell? How thick is the shell? Right? And so some information, the PBDB has that information, but not all of it, because it's not required. But different research groups might use that. But the PBDB does not enforce corrections or accuracy on that stratigraphic unit name that we join the databases, right? So those rock unit names, the PBDB has no way to check that, whereas MacroStrat, that is explicit part of its, foundational underpinnings. And the MacroStrat encompasses all geologic time. So the oldest rocks that we have on the North American continent, which approach 4 billion years old in the Canyon Craton, to the youngest cover, was the PBDB only covers those periods where we have large complex fossils. And again, geologic unit names can be misspelled or incorrect in the PBDB. The age range of all Ediacaran fossils, so those earliest animals, they're all 539 to 635 million years, which is 96 million years. So if you were to plot that in terms of biodiversity, it'd be a flat line, right? So I had to come up with a way to enforce an age on those using the rocks and an age model that came from the rocks that were contained. And PBDB for the Ediacaran was incomplete. I had to go in and enter data that didn't exist there because, again, people enter these for different purposes for their own research. And the entries include trace fossils, some taxa that were not animals, taxonomic problems, inherent preservation bias, etc. All right. And then finally, we were able to put together, once we got through all these challenges, though, we can do things like what might actually be driving fossil diversity during the development of Earth's oldest animals. And what you're looking at is all the blue diamonds are where there are fossil occurrences that are contained within rocks of those age. And then the colored polygons are where rocks of that age occur. So what we're seeing is from where the oldest animals appear in the Ediacaran, we can then watch as the actual area preserving marine rock expands, which is the flooding of the continent during the Cambrian, and the fossils are tracking that flooding of the continent. So sea level was an influential factor in the origins of the earliest animals. Okay, and that is all I want to I'll pass it on to the next thing before I can go.
Hi, everybody. I'm Steve Diggs, CCOP, and I'm gonna run through stuff really fast. So just like I was gonna say that mine is paper and then there's gonna be a scissors talk after the rock talk, but that probably won't go over very well. I'm here to talk about robots, ships in the deep blue sea, and integrating between two basic programs where they're measuring the same thing, but they're both an incomplete picture. And to get a complete picture, we need to put these two things together. So, snatched from today's headlines or Tuesday's headline. Sunday was the world's hottest recorded day ever. And the previous hottest recorded day wasn't much before that. And so we're in an age where we need to figure out what we need to measure to figure out what is going on with our warming climate. As it turns out, for those of you who forgot all of your black body radiation, I'm here to refresh you. We got about 350 watts per square meter coming down. We have just about everything going back out in almost a perfect black body, but we have that 1 watt per square meter. And it turns out to tease out what we need to measure the ocean because the cryosphere and the land are not very good at holding heat. The air is not very good either, but it mixes really fast. And that's what most people will tend to measure. That means we need to get this heat flux, we need to measure it very carefully, and we use a variety of instruments and platforms. Not all of them came along at the same time, not all of them measured the same thing. So the global ocean observing system has lots of components. You don't see satellites on here, but you see lots of dots. The time is compressed. We're just going to talk about two. One's a robot, the yellow thing that's circled there, that's an Argo float. And then we have things that are lowered from ships, the Rosette, with lots and lots of instruments on it and takes more precise measurements. So the thing that's lower from ship, it's called Rosette. It has a bunch of instruments on it, but one thing it also has is an expert crew. That expert crew, after every measurement, makes sure everything is nice and perfect. There's lots of instrumentation on the ship where we take the water samples and we put them in, and it is very time consuming. The downside is you need a ship, and you need about between 45 and 90 days to do a series of measurements, and you can't do it that often. More modern is the robot, Argo float. It goes down to a parking depth of about 1,000 meters. It hangs out for about 10 days. It takes a deep dive and comes up and transmits with its little iridium transmitter and comes back. You can see the spatial coverage there, and you can see the relative size to human being about 2 meters. I had a chemistry teacher come and stay with me for summer, and she worked in the Argo lab. So we got down to 2,000 meters. We have something that doesn't require personnel. There is a wrinkle here, is one is used to calibrate the other. So we use the thing with people on it that are taking very careful measurements to make sure that the sensors aren't drifting in the instrument that's out there for 5 to 7 years. And yes, they do drift. That's kind of how that story is. But it's used in studies where we can actually tease out where the ocean is actually going. My apologies to the online people for drifting away from the mic. Can you hear me in the back? Yes? Okay, so here's a comparison chart, and I really don't expect you to be able to read all of it, although you'll be tested on it in just a second. But the stuff in yellow is probably the things to highlight that should get the juices going in your head about what the challenges might be. For instance, the measurement depths are different. One can go to the bottom of the ocean routinely or pretty close. The other can only go down to 2,000 meters with most of the instruments out there. One platform has about 4,000 points or so, making simultaneous measurements most of the time. The other has one ship at a time out there, maybe 5 to 10 if all the countries are cooperating at the same time. The data release policy, one is instantaneous, one takes a lot of time. And then the cost per measurements are kind of a big deal, but may not figure into the integration. For one is about $200, and the cheapest I could get a ship measurement is about $10 billion. So this is kind of pictorially what it would look like. And now we're going to get to the Slido.
Or not.
That was the fastest dilemma I've seen in ESIP so far. It's like, oh, okay, it's all. So, you know, Slido do your thing. Sparse, kind of a problem, yeah. Time, not a problem. Spatial coverage, yeah, kind of. Misaligned scales, close. Consistent correction, spatial temporal difference. And everybody's getting in the space and time difference. That's actually the beauty of these things, is they're both accurate in space and time. Nothing ethical. That long, not much of a problem. Sparse ship there, calibration. There you go. You're getting there. Floating location. Kind of a problem. Variables collected. Now we're getting more. And people are a problem because, you know, people are always.
Okay, we'll keep that going and switch you back to. Workshop.
All right, so since we all failed the test, turns out that things are called different things because these two programs grew up separately, even though many of them had the same people. Is not everybody calls temperature, or salinity. We did have a test where we were able to do it with a program called Ocean Data View, and we were able to reconcile things by forcing the metadata together, mapping by hand. But you need to do this on, you have 40 something gigabytes of Argo data, about 4 gigabytes of the high resolution data. You can't do this by hand. This is just an example. So the ship data looks like a table of CSV, human readable, and things are called things that came from the Microsoft days when you had 8.3 and everything we were trying to save on space. So all vowels were moved. The Argo data is in NetCDF. And so it adheres to the CF standard, so you can actually use real words. And so you might say a machine could map between these two, but not automatically. So sometimes things are misaligned. Sometimes mass units and volume units are confused because people fill in a template by hand. And so with oxygen measurements, it's very difficult to tell if it's mass or volume, just because of the nature of oxygen, soft oxygen in the ocean. So you can see these things are called different things, and that is the crux of the issue, is to get things called, do the mapping consistently. The biggest problem is people's workflows. And that is you have a bunch of almost golden age oceanographers, because it's such a young science, have workflows that are still in Fortran, and they know how to process text files, and NetCDF scares them. But what people fear is not change. If I gave you $3 million today, that's a huge change. You'd love that. That's change. But what they fear is loss, that their workflows will have to change. And there is no amount of human convincing we can do that is just a couple of lines of code and you're good to go. Turns out that we were able to successfully integrate things, and you get products like this. Where you can actually do really kind of cool animations and just skip around and actually do science instead. And that's all I have, and I'm going to hand it off to the next speaker. Thank you.
Great, thank you. So like Rachel said, earlier, my name is Natalie Rea. I'm a postdoc in the College of Information Science at University of Arizona. And thank you for the opportunity to speak today. I'm happy to share today some of the work that I've been doing in collaboration with Andrea Thomer, also at University of Arizona, as part of the FAIROS Ethical Open Science for Past Global Change Data Research Coordination Network. It's a mouthful. And share some of the work of how we've been thinking about data integration within the paleoecological and archaeological domains. And so just briefly, what is the FAIROS Ethical Open Science RCN? This is a 3-year NSF funded grant that brings together data practitioners across several paleoecological and archaeological data resources to improve interoperability and reproducibility and to advance data curation and stewardship for these communities. And so in particular, we're doing this by trying to chart a path forward for better implementation of FAIR and CARE principles within some targeted data resources. And so we're really trying to reach across these silos of excellence that Alicia was referencing earlier. And so we're accomplishing these goals through several concurrent efforts, which are shown kind of represented by that circle on the left. And today I'm going to be talking about some of the work in progress that Andrea and I have been contributing to the RCN's efforts. And so our goal with this project is to map the quaternary informatics landscape. And so by that, I mean mapping the network of data resources that serve disciplines that contribute to our understanding of the recent geologic and historic human past. And so this would be paleoecology, it would be geology, archaeology, and so on. And this is a research space that is concerned with topics such as climate change, human and animal migrations through time. And they have a number of cross-disciplinary shared data types, such as stable isotope proxies, various chronological methods, such as radiocarbon ages. And from a metadata perspective, they have similar spatial emphasis and challenges related to key sites and importance of stratigraphic levels, some of which we heard Daniel just talking about a moment ago. And so we're interested in assessing the scope, the coverage, and the connections of relevant repositories and data standards that are used by these disciplines. And so we're asking, what is the coverage and completeness of the quaternary informatics data resources? To what degree are these repositories interoperable currently? And then what standards and best practices dominate the use of these systems, and whose standards and practices are marginalized or left out? And so I'm going to focus on just one method that we're employing to answer these research questions. And that has been engaging with the community of data resource users and data resource managers through semi-structured interviews. And so these are interviews that are about 45 minutes to an hour long. They're generally one-on-one, though we've done several group discussions as well. And we ask a range of questions, open-ended questions, some of which I'm showing on the right-hand side of the screen here, that relate to people's usage of data resources, their challenges related to working with these data resources and across the data resources. And so again, that's this data integration piece, and then their needs and visions for future systems. We're also asking them questions related to data ethics. So this is that care part of the work, and I'm happy to speak on that in discussions and questions later. And so with that little bit of information, we're going to switch to the slide. Okay, so we have some responses coming in different formats and data formats. Terminology, definitely. Time, the time has proved to be very important, surfacing in interviews, dates and time. Naming conventions related to taxonomies. Missing metadata, absolutely, I'll touch on that in a second. Highly varied data. Yes, human subjects concerns. So that relates kind of to our actual approach. So this work that I'm presenting on, we've gotten IRB approval through University of Arizona. Great. And so we've conducted interviews with 24 participants thus far. And again, this work is ongoing, but some higher level successes and takeaways that the interviews are kind of yielding. First, this approach has yielded really rich data about what data managers and users like about the resources currently, what they need, and then what they want from data resources in the future. And there's certainly information held in just comparing the responses that we're getting from data managers and then the data users as well. Some examples of a broad theme surfacing from the interviews, like Steve said, people are always a problem. So social and community consensus challenges, over technical challenges are more often the limiting factor for these communities in making progress on interoperability. Back to the missing metadata point that was raised in the Slido. The metadata required to enable reusability in one domain may not be collected as part of the standard practices in another domain. So this really hinders the reusability when you start to talk about cross-disciplinary usage of these resources. And then kind of harking back to some things that Alicia alluded to in the intro, more robust provenance metadata fields related to data collection context and purpose. Again, thinking about cross-disciplinary applications, having users have an understanding of why that data was initially collected. Data processing and methods are a key priority across all of the disciplines and users and managers that we've sampled so far. What's been working? The combined approach of talking to data managers and users has been really critical to this. And then the group interviews with data managers have provided useful time for these leaders to reconsider their data integration challenges with new prompts and questions. And that's kind of been there wasn't something that we predicted, but it's been really interesting to see how that's played out. Topical scoping is key here, which Alicia had also talked about. Recruiting people for this can be challenging. So your engagement and outreach plans are critical. And then really, really critically, I want to emphasize that we're employing a social science methodology here. And in any situation where you're going to employ interviews, focus groups, or surveys, this requires dedicated expertise, time, and attention to execute effectively and appropriately. And that's a key issue for me personally, because I'm a geologist by training. And so taking on some of these methods really requires a team that's equipped to do that. And I will leave it there. We can talk about this more in discussion.
Okay, so we've got a little bit of time to basically just have an open panel discussion now. Does anybody have questions for the speaker? There are questions in Slido. Excellent. Okay, there's a question that says, are federated systems or open science platforms improving the challenges of data integration from different data repositories, or what can they do better? Any of our speakers want to? Steve has a look on his face, if he might.
It's probably not the answer you want to hear. Oh, I want to know what federated systems there are. Truly federated. I think to have a federated system helpful, it has to be in use, and it has to be well populated with data that are useful. So I would say that the open science platforms are starting to make a tiny dent in attracting the right kind of data, but I'm not aware of really commonly used federated platforms. So I'd love to know if you pose the question, what platform you're talking about.
And the field's open for anybody online or in person. If you have a comment or another point you want to raise for that, that's
Hi, Bob Chen. I have a different question for Natalie. Natalie, you mentioned human subjects as related to interviewing data managers and users. But does any of the underlying data that you're incorporating have like individual data, human subjects data or,
Yes.
indigenous data sources? Yes.
Yeah.
it is. Yeah.
Yes, thank you
what
for
are
raising
they?
this. So that's been that's part of the efforts of some of the other teams in the RCN, looking specifically within their own data resources. We have the Florida Museum of Natural History that's doing some of that work and figuring out what to do with that data. Do you remove it entirely? How do you work with indigenous communities to allow their perspectives on what should be done with that data? And a lot of that is legacy data. So yes, there are those concerns. And one of the big things that we've been talking about across the RCN is when you start to talk about building interoperability, and that data propagates outward, how do you build in technical mechanisms to ensure that when edits do happen related to identification of those types of data, how do you ensure that the rest of the systems know that that's happened? So we don't have solutions yet per se, but it's something that is a big focus for the RCN.
Any other questions in the room?
So data integration is challenging because the first time through is always a bespoke exercise. But gee, wouldn't it be cool if we integrated type A with type B? No one's done it before. But until you try it, you're not going to understand how to design a system to enable it. This question of sort of, just to pick on one, the rocks and fossils. So once you know how to do it, now we have requirements. We can build out a system to help solve all the issues you addressed and made progress on it, on solving. So I struggle with this sort of mass customization. How do we take the lessons from these initial bespoke exercises and rapidly get them into the core platforms?
Yeah, and your example is really good because one of the next big projects we'll be working on is doing that not for just those two time periods, but all the rest of the 500 million years of the Phanerozoic. Because I've done it once and meshed it, now I have the system in place to do it. But like you said, and one of the things we had talked about earlier in the session is kind of categorizing some of the challenges that are faced as things that are domain specific, right? There are things that are very specific to whatever data sets you're meshing, the problems you're tackling, et cetera. But then there also should be some more generic things that maybe we can provide guidelines on or develop a process for, or just even making a PSA that be aware of these things when you mesh data sets and not just taking them at face value, but trying to understand their architecture, so on and so.
Yeah, and I would, I'm going to hand this over to Steve, but I would echo, I think what Daniel said, and partly why we asked Natalie to speak too, is because ways to get through those silos of excellence so that you can have more applicable methods across domains requires you to listen to people across domains.
Yeah, my old boss, every time we went in the field, he said, well, once we do it, we'll know how to do it. And that's very true, right? But more than that, once you've done something similar, you may be able to build sort of generic templates on what to expect or what you know that you don't know. Like we hadn't run into the oxygen problem before we did it before, and we were deep into the integration and had done it wrong and then needed to back all of that stuff out. So the next time we integrate a new parameter, we're going to be much more careful with units and talking to the experts and making sure that happens. And I think the second thing is that when you say that you've done it, I think within, and we have a very academic culture, so people tend to huddle down and do their own thing, answer a paper, and then they go on to the next funded project. Instead, I think with the philosophy of open science, we should start thinking our first reaction should be, I need to share this information and put it in a clearinghouse and create a recipe so other people can see what I struggled with.
So if you read a lot of, literature review sections of journal articles, a lot of them are 7 people have tried to integrate these 2 genres of data, and here are the 3 different methods they came up with, and they're all flawed. I'm going to propose method number 4. So there's no standard answer. It's the scientific process that's always going to be improving the integration methods. And so I'm struggling with how to, yes, there's certainly things we can do in the sort of data stewardship world to aid that process, but we can't automate it, I guess is what I'm trying to get at.
I mean, what role does standards and interoperability play into making bridging these silos, right? I mean, I understand when you have folks from completely different scientific domains, they have different standards. But sometimes you have people in the same domain. We talked about people on the same ships who can't even agree on standards, who can't agree on I mean, some of this stuff can be easily solved if the people just got together in the community and just decided on interoperable standards and actually followed through with actually using them. I mean, to be honest, I'm kind of being facetious, but I'm being honest, right? And then you see even metadata, right? We deal with metadata all the time in the EOS DIS, and it's really, really hard to do search and discovery when there's so many different standards, when folks haven't agreed on how to populate the metadata. It further complicates, it makes an already complicated problem exponentially more complicated, right? And sometimes I feel like we contribute to our own pain. That's my comment, right?
Okay, one more comment and then I'm going to move us on.
Just wanted to loop it around to the first question that Steve started addressing of federated repositories and then looping it into the interoperability and making sure metadata. So within the marine world, we have this data service called ERDAP, and that's what a lot of repositories use. And you can actually use it. You can federate ERDAPs to search multiple ERDAPs. I've tried to use that. You still run into the same issue of people aren't following the standards or they're just doing nuanced different things. So we still run into that, and it ends up being a people problem.
Okay, so we'll come back to the fact that data integration is a people problem. So we're going to have there's a few of us that were at the persistent identifier talk yesterday. We're going to have a birds of a feather table during lunch today. If anybody wants to join us to talk about linking identifiers from samples to data to processes to publications, et cetera. So come join us if you want to talk about maybe trying to actually weave a thread through some of that. And I would argue to the gentleman in whose point about like, we can't really automate that. If we could agree on standards, let's automate the boring stuff that we don't actually want to do and save the integration challenges at the edge of that spectrum that's actually interesting and actually requires human brains to solve. So that's my soapbox for that. So I'm going to move us on. Okay, so now we're going to go into breakouts. I'm going to give people probably 15 minutes or so to do this. We have a little bit of time for report out at the end. In the notes document, there are little tables that you can start to share your data integration story. So the online people, I think we're going to put you in a great breakouts of 4-ish. So feel free to grab a spot in the notes doc and do that. For the people in the room, I have a couple of printouts if you prefer handwriting to get your brain going, and I've got some sticky notes, or you can use the online notes doc as well. I don't have enough printouts for everybody because there's a lot more people in here than I was expecting, which is great. So please think through what your data integration story is. What is your question? Where on this data spectrum does your data integration question lie? What worked and what didn't work? And then what did you learn? What mistake do you not want to make again? And then start to think through what those higher level challenge bins are. Is it language? Is it scoping? And so start to think through some of that. I'm going to give everybody probably about 5 minutes or so to kind of fill out the form, think through your integration story. And then we're going to go into groups and you're going to share a little bit. And I've got Post-its for the people in the room, or you can just make a comment on the online doc. If someone's telling you about a challenge and you think they might have missed a challenge or you want to reword a challenge, go ahead and make a comment. So the goal for this is at the end of it, I'm going to have a bunch of integration challenge stories from everyone in this session. Cool. Okay. People in the room who wants to do old school style? Otherwise, feel free to use the doc online. I have one old school piece of paper taker. Two. Okay. So right now you're just going to work on your own. And then in about 5 minutes, I'm going to ask you to chat with your local neighbors. Mhm. And the online document should be linked in the Sketch session. Yeah. Is everybody else able to get to the document? Anybody else in here want a piece of paper? So take a couple minutes and think about, please put your name down if you're comfortable with that. What your science question was, where on the data spectrum, and I'll leave this up. What worked, what didn't work, any lessons learned, and any integration challenges that have come up, or if you have new challenge bins you want to propose. Okay, thanks everyone. I muted the room so that we didn't completely just blow out the Zoom group. So the Zoom breakouts are now back. We had a lively discussion in person too. It was just this like hum that started all at once and it didn't stop until Steve had to whistle. So thank you. Okay, so we're gonna do a couple of report outs. I tried to leave a little bit of time so we can share. In the room, I passed it out some Post-it notes. If there are sort of general challenges that surfaced, please write them down on there. Make sure we're gonna collect all of these at the end. So we're making sure we're capturing everybody's sort of shared challenges. But I would like to do a couple of report outs for people to talk about their group, what the discussion was, the range of science questions maybe you talked about, the range on the data spectrum that the data was integration challenges were happening, and then what was the most common data integration challenge that surfaced, and any new ones that weren't covered. And can we do the online people first? Does anybody from the online community want to share? Since we don't get to interact with you as much. Should put them all on the spot last minute. While we wait for an online volunteer, does anybody in the room want to share? You guys all had a lot to say. Come on. Yes, please.
Thank you. So I would put out a challenge that I've run across in many situations where if you're taking data from different disciplines and trying to use methods of different disciplines, the methods that work across disciplines aren't necessarily the state of the art in that discipline. Therefore, when a disciplinary person looks at what you did, they say, oh, that's old stuff. We did that 10 years ago. But the point is, what you did 10 years ago can be compared or integrated with what other people are doing. And that's the innovation, but you get a lot of pushback from, the non-disciplinary people who don't understand your problem. And therefore you face this challenge of defending what you've done.
Yeah, that's a good one. Thank you. All right, Colette, anyone online? I'll be brave. We're here for you. All right, Daniel in the front.
Yeah, now Natalie and I were talking about, she said in some of the workflows that there'll be a larger database or data platform that gets used. But then you have researchers who are really in the workflow of that platform, and then they may miss smaller databases that they've swept up into their larger compilation that they're just showing their workflow, that they're not necessarily capturing those smaller data sets that are, out there and, getting integrated into their, larger thing that meshes with their data before they even start to integrate it with something else necessarily.
It's hard to know what you don't know, basically.
Right.
It heard a lot of talk about crosswalking and data crosswalking is something that I actually do a lot for a lot of different databases. But one of the issues I ran into building a combined wildland fire data set for the US here is that people use actually the same terminology, but have different definitions for the same word. And so there are a lot of dates in fire: start date, discover date, containment date, control date, out date. And my colleague and I were just gonna put all these as, that's so important. We need to know all these dates for the fires. And the group of experts I got together to help me with this said, oh no, like these people use this definition for the start date. Well, these people use the discovery date for the start, and you can't combine these different data sets because you don't know. And there's nothing in the metadata that tells you what date they actually used. And so we ended up having to almost just kind of put all the dates into one common field because they told us we couldn't trust the data because they were using the same field name and defining it in very different ways. And that presented huge challenges for us to try to combine data sets.
I mean, even trying to like define data integration for you, you see how I pitched that, right? Like I'm not going to, I'm gonna give you an option, but that doesn't work if you're having to combine data. Anyone online yet? Okay. Anyone else in the room?
I just have a quick follow-up to that point about the dates, and it sounds like the challenge there was the lack of metadata. Because if everyone used start date with a different meaning, that's a big problem. But if they at least define that meaning, then that's a little bit better. Define it in the metadata. And so I think one challenge is integrating metadata creation as part of people's workflows when they create their data in the first place.
Yeah, how many people work with data dictionaries? Yeah, right. So there was interesting conversations yesterday about putting LLMs on some of this. Well, it's not going to work unless you've got a data dictionary. It's going to see start date and start date. Assume it's the same thing unless someone's defined what start date means. Final thoughts online or in the room? We can do two. Go ahead.
Yeah, I think something that maybe is seemingly trivial and is actually quite easy in some cases, but pretty hard in other cases, is just determining the co-location of different data sets, like determining whether two things are actually at the same place. Starts with projections, datums, but then goes also into the situation where we have observations that are not zero-dimensional, but cover some area. If it gets worse, they have a point spread function under them. So how do you exactly do that? I think that's a huge challenge.
Yeah, and one of the CARE principle related topics that we're dealing with is precision of latitude and longitude. And there are some places they don't want you to know exactly where that sample is collected for very good reasons. One final thought. Okay.
So we talk a lot about missing identifiers, so not having persistent identifiers. But in some of the work that I've done, I've run into scenarios where persistent identifiers are used, but they are not correct. So it's the wrong persistent identifier, and I was specifically thinking about people data and like use of orchids where, John Smith provided Jane Smith's orchid, which isn't right, or mistyped their orchid because they couldn't select it. They had to hand enter it into a system. And so, yes, just having persistent identifiers doesn't mean, I don't know. you need to ensure there's some data quality there.
Accuracy of entry of data is always for sure. Okay. Okay, so thank you everyone for participating in that fun little exercise. Hopefully you found it to be somewhat stimulating and not just totally frustrating. Today we explored ESIB's data integration questions and challenges. So what are the next steps? So again, we had a couple of science use cases, one on fossils, one on ocean data. And then Natalie presented a conversation around how do we actually learn more about this? And so we're going to bring all that together and hopefully design a survey to help us learn from additional ESIB members some of these same questions and conversations. So if this was interesting to you, if you are interested in continuing this kind of conversation with your fellow ESIB members, please start coming to the data stewardship meetings. It's the second Monday at 12 p.m. Pacific time, 3 p.m. Eastern time. And I got a question about why are we doing all of this? Well, the goal, I think, for the Data Stewardship Committee, since I'm now in charge of it, my goal for the Data Stewardship Committee while they're stuck with me, is to learn how to communicate challenges across these different ESIB communities and identify areas where we as a Data Stewardship Committee can start to partner with other groups, maybe the persistent identifier group, maybe the samples group, whatever it is, to start to solve some of that. So if we take kind of a comprehensive survey of members of ESIB and what their challenges are and start to bin them at that high level category and work with the other ESIB committees to figure out, is there a place where we can start to work together to maybe start to address some of these challenges? So I'm a very solutions oriented person because I don't like being frustrated continuously. And so please come join us. We would love your name. If you have your name in the notes, put a couple asterisks by that, and I'm happy to reach out to everyone after the session. We would love ideas on how to solve some of these problems as well. So with that, we are 1 minute over time. You're free to go. I'm going to leave this up. So if you want to go to Slido and give us a rating on the session, you can do that as well.
That was a good session.
Thank you.